Now, so moving to then we are going to now look into the grid search in hyperparameter tuning. So how do we carry out the grid search in WEKA environment? So how do we go about the grid search in WEKA environment? So we follow the same procedure, but this time around, to carry out to use grid search, you need to make use of the experimenter option here, not explorer. You go to experimenter, because here you are going to set up several experiments, and then you cannot click run, and it will run all these experiments, and then it will put your result into a file or in your database, preferably a CSV file that you have created. It will put your result there. You can now open the file and then take the result, make plots to be able to determine what is the hyperparameter value that's working best for my data set. So now let us go ahead with this. Let's say we are clicking an experiment. We choose the experimental option. So here, so we have the experimental option. So you can see it here. This is the setup page for it. I have to start by setting up. We want to use the grid search approach. So, and what is grid search approach? This is where instead of manually doing one by one, I want to set up several search possibility. See, grid search approach can be possibly compared to something like this here. So you have several options that you want to search for at the same time. So this can be, maybe this is my kernel option. I set up all the kernel options, polynomial, RBF, I set them up, and also set the K value up. K value could be 1, could be 4. So when it is a polynomial, I check for 1, 2, 3, 4, all the option of K. When it's RBF, yeah, it's like more of a kind of super manual, but then this one is automated. The system will do that for you. You will not be doing it one after the other. You just set it up and you can click run, and then you go back, can click run and then start doing other things, and then you come back and then you can see the outcome of the run. So in brief, so this is the setup page. The first thing to do here is to click new. So you want to set up a new experiment. Yeah, there's the simple one, there is the advanced one. I recommend the simple one for you. The advanced one has some other complication that you might not be able to deal with at the beginning. So let's look the simple one. So then once you set it to simple, this is the default value, by the way. The default value is simple. Then you click new here. Click new. So I want to set up a new experiment. You can see some functionality has been activated. Now let's pay attention to this. Now after you click new, now you can see here, this is result destination. Where do you want to put the result? You have to set that one up appropriately. So you need to go to browse to a place whereby you want to put, this is by default, it's taking me to the C where the program is installed. But from example, if your machine has security feature, it will not allow your software to write in that particular C, so it might generate error. So I recommend don't write it on C, try to write it in another drive. Usually I have my own working drive, so I'm going to save it in results. Yeah, so I don't want ARF file, I don't want the WEKA standard file, you might not be able to interpret it. So I want to make it show me all file. So I want to create the CSV file. So I can call it result of grid 2023. Just give any name that you can remember. So the CSV, yeah, this CSV file. So I've stipulated, I just indicated the outcome of the experiment where I want the result to go. Now, so it's ready. The next is to set up how I want it to be. Now, let's look at this, please pay attention. Now we have to, you can see the first panel and the second panel. This panel, sometimes you want to, actually you can do experiment for multiple data sets. So that's why you add different data set here. Add first data set, then come here and set up all the hyperparameters for that data set. You can add another data set again, come here and set up all the system. Add another data set. You can set up many experiments, and then you want the result to go into Excel. You can go and sleep, and then after a few days, you come back to your machine and start processing your results. This is the essence of the experimental option in WEKA. Now, for this case, we are going to use only one data set. Okay, so in that case, we are not bringing multiple work in that respect. Also, we have to select here, are you working on regression or classification? Let's say our data, the default is classification, but you can always select whatever you want. Now, then how do you want to test your data? Do you want, for hyperparameter optimization, how do you want to do it? Do you want to have train test percentage splits, randomized? Every time it's going to randomize it. Or you want it training test percentage split, ordered, preserved. So the same order it used for case 1, it will use it for case 2, it should not be randomizing it, which is better. However, as we mentioned last time, if you want to do hyperparameter optimization, it's good not to use the test case, the test partition for the parameter optimization. So you can remove that 20% out of your Excel file and then use cross-validation. Cross-validation is still one of the best options to use for hyperparameter optimization to ensure that your data partition is not just, your performance is not just because of the kind of training set you have selected. But cross-validation will make sure that all the data sets are used as testing and as training at some different point in the partition. The number of folds for cross-validation has to be stated. Just like if you are selecting partitioning to training testing, it will ask you for the partition you want. The default is 66. You can change it to 80 or 90 or 70 as you wish, but 90 is getting too high. So the same way for cross-validation, we have to indicate how many folds do you want to choose. If your data is big, then you can use 5 cross-validation folds. So that to reduce the number of partition is going to be 5. That will run it 5 times and get the average of the results. When you use 10, it's going to run 10 times. So if you think you know your data set is big, then perhaps it's not good to use 10-fold. You can go for only 5 folds. And your data set is really very small. Even using 10-fold will not make any sense at that point. You have to use very small fold to make sure the data is representative enough. Now, once you have done that, so now you can now do the kind of which kind of iteration you want to have. You see, I'm going to be setting up the algorithm that I want. See, I'm going to set up the algorithm that I want to look at. Now, this is where we have to pay attention here, very important. Now, if I want to randomize or I want to do different experiments for different data sets, I'll be looking at this, but I'm looking at the algorithm actually. So here we have to add the data we want to use. Don't forget, of course, this is the most important there. So open your data. So use your data, or maybe we want to change it. It's okay. No data is there. If data is there, you have to change it. Always remember you have to click here, use CSV data. So this is a hypertension data set. The system can use that. Okay. Now, so I set up the data. I'm using only one data for now. If you want multiple data, you can add them, and then you can set up the kind of rolling it out here, but we are using only one. So now this is where you select your algorithm. So we want to work with algorithm. Now, you need to add which algorithm do you want to work with. I want to do hyperparameter optimization for k nearest neighbor only. And if you want to do for 3 or 4, you can add all of them. So let's start with k nearest neighbor. So then you're going to add, then you see here, you're going to choose the algorithm you want to use. So let's go for the lazy classifier, IBK. Yeah. So the first one is case 1, and the default distance measure there is Euclidean. We are going to keep the Euclidean constant for now, while we keep changing the KNN, sorry, the number of K. So, okay. Then add another one. So, since we have selected IBK, there's no need to change it here. we just change this to 3. Number k is 3. Add another one, we change this to 5. So the same thing we did in the manual case, now we are setting it up. Yeah, so set up, this is 9, 11. Let's stop at 11 for now. If you like, you might want to add one, maybe 13. Okay. That means for the Euclidean distance, we have asked the system to repeat it for k is equal to 1, 3, 5, 7, 9, 11, 13. Now we need to add more. Now you go inside and change. So the next is shape distance. For shape distance, you know this is 13. You can try in reverse order, and if you want, you can start again. 1. K is 1. Because we have changed the distance measure. Then we have to start searching for when k is 1. Again, add again. When k is 3, add another one. K is going to be 5. Add another one. That's a 7. So we keep adding. That is up to 9. We are going to 13, 11, and finally we have 13. So we are setting that up. So now we have for the shape distance. So again, you go inside again, you continue with that. You're going to go inside again now and change the distance measure to maybe you want Manhattan distance. The same way you start again with 1. If you keep adding the number of k you want it to search. If you want it to search even more, you can add as many as possible. But from experience, mostly k nearest neighbor between 1 and 13, maximum 15, 17, you get the best result you want. This is from experience. Again, sometimes your data set might say no. So whenever you finish your hyperparameter search and you open this Excel file, and you notice that the performance is still increasing until the end, it means the value you have searched for is not exhaustive enough. You have to go back and start from where you stop, you see, and then start searching forward until you get the best you are looking for. So this is why, but for the meantime, you can restrict yourself to, we are restricting ourselves to 13. After 13, we change the distance measure, and we do this for that. Now, the next is, let's say, you can complete that one for 1, for Manhattan distance, complete to 1, 3, up to 13 again. And you can also, next, I want to set up, let's assume that I've tried for all the distance measure in k nearest neighbor. Then I can go ahead and add another algorithm now. So I want to add support vector machine, the SMO, the one we worked with just now. So you can add it here. See, and I told you in SMO, the most important is the kernel. So the first one is polynomial kernel. We're going to keep others fixed, that this is C is 1. Keep this fixed for polynomial kernel. And then next, we are going to add this to the system. The next is I'm going to choose another one. I will change the polynomial kernel to be maybe normalize polynomial kernel. I've changed it again to another one. You keep doing that. PUK. I change it to another one. RBF, because they are the most important. They change it to another one. The string kernel doesn't really work for numbers. We have to be very careful with that. So the others we have selected, we most likely work. Yeah. Once you are done with that, then you start maybe adding another one, RBF, by changing 1. The one enter before was 1. You can change it to 10. So again, add another one. Change this one to maybe 100. Add another one. Then we kept this one, RBF is kept constant. And then we keep changing this one. This continues. Let's say we say 1,000. So you set up all the possibilities you are looking at. If you still have other algorithms, you can add up them. So once you are done with all the algorithm settings you want to search, then the next in is for you to go to run. You pay attention to that. You go to run, and then you can click run, and then you can click start. So start means all the experimental setup you have provided here, you are ready to let them go. And then we can click run, and then started, and then you can monitor the progress in the here. You can see here, it said iteration, classical 1 is changing the iteration, it could continue. So you can then go to your file and start monitoring the file you have created, the CSV file where the result is going to be. You can actually open the file and then, but it will open it for read only and then see what is inside. If it's not yet completed, then you can close it. Whenever later you come back again, you will see that it is done. Started means it is working, it is not yet done. And if you like, you can stop it. So this is how we set up a grid search in the WEKA environment. And like I said, you can set as many algorithms as possible, and you can also actually set up experiment for different data sets. So you have multiple data sets. So once it finishes one data set, it will jump to another data and then start the process all over again. So this is what we do. Once you are done with that, then you can go to your data set. For example, you have to go to where you store the data. I think the data is stored here. Yeah, sometimes here, the results. Yeah, so you can see this is the result of grid search. Yeah, the result 1. So you have to keep checking it until it is done. Once it is done, then we can open it and then see. When you open it, you are going to see something like this. So the one we started is still running. This is just an example. So we are going to see a kind of this is the nature of the Excel file you are going to open, the CSV file. You can see here is the first one is the data set. Like I said, you can iterate data set. So you can make different data sets to be changing also as you go. But it's only one data set. It will mention the data set I'm using. It will mention the key run, how many times you want it to run. Then the number of fold. You can see here, it will monitor fold 1, fold 2, fold 3, fold 4, fold 5. This is the result as it is going. See, the number of fold, we set it to run for 5 folds. We set it to for another 5 fold. And then at each level is going to be changing the value of the K. You can see K is 1, K is 1, K is 3, 3, 3, 3, 5, 5. It keeps changing there. So all the result options will be in your Excel file by the time it is done. However, let me clarify something for us quickly. Let's forget. Yeah, this is one we started. Take it still running. Yeah, it's still working. It's still working. Yeah. There's something now, we have started the experiment. This option, we are supposed to change it. Though it's not compulsory. Number of repetition. So what we have done now, the one we've just started, we've asked the system to iterate 10 times. So for every experiment you have set up, it's going to do it 10 times. And since we are reducing cross-validation, there's no need to do it 10 times. So we are supposed to change this to 1. So let us pay attention to that whenever you set it up. Number of iteration or number of repetition is 1. Repeat it only 1. Because cross-validation, we make sure you repeat 5 times already and find the average. So there's no need to do repetition again. We can use this repetition if we are choosing the option of training and testing percentage split. Then we want every percentage split to be randomized and they'll do it 10 times or 5 times. And then they can find the average. This is when we use that. So let me clarify that one. So here you make sure you set it to 1. So each experiment will be run using cross-validation. 5-fold or 10-fold is up to you. So this is how you set up a grid search in the WEKA environment, and your result will be displayed in an Excel form where you can analyze the result. You can see here, go up. These are your results. You're going to see the result. You can see percentage correct. This is the percentage of correct classification. You can see 67, 66, 68. You can see it's changing. It becomes 70, 71, 72. It becomes 72 here. So you can see here that at the end of this experiment, for example, there's an example for you. We have 72. And it means it is still increasing. That means my stopping at K is got to 11. It's not enough. So I'm gonna have to go back again and set up another grid search to search from 11 to maybe 13, 15, 17, 21, and then run it again in a grid search and see the result. Because in as much as you see the result that is the performance is increasing, it doesn't make any meaning to stop. But then you don't know where it's going to be. Sometimes you might get the best result in one at the beginning, and subsequently it will be reducing in value. So there's no need to waste your time going to 17 when the best value is one. So when you analyze your Excel file, you'll be able to know that, oh, the result is increasing. Even at this 11, it is still increasing. So I need to do another search, starting from 11 up. So this is how you use, okay, even when you use Python to write code, you cannot search for all possibilities at a go. Otherwise, it will run forever. It will not stop. This is why grid search, people run away from it because of computational complexity problem. So the way out is to make sure that you make a guess of start from 1 to 11, get it. If I don't get the best in this range, increase the range again in another section of the grid search. This is how you do grid search. If you say search from 1 to 1,000, it can run and run forever. It will not stop. Sometimes your system will crash, especially people who does experiment with a laptop. Your laptop can restart itself automatically if it gets really in a trouble. So this is how we can implement grid search for hyperparameter optimization in WEKA environment. So, and I hope that is clear and clarify things for people who might be interested in that area of search, either manual or grid search. You just have to be meticulous and careful in following the stated procedure. Thank you very much. We can take a few comments or questions now before we call it a day. Thank you for listening and wish you all the best.